Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and very good day. So today I'm going to continue our discussion on this course MGHG 1114 Principle of GIS. So this is our chapter 4, discussion on the chapter 4. So this chapter is about attribute data management. So this is about what is the location is all about. We will discuss how this data has been developed, and then how to manage it, and then we will discuss later on the step or the life cycle on developing a database. So this attribute data management focus more on the database or behind the information of the attribute data in GIS. Okay, some content. The first one we discuss about the introduction, and then the importance of database, what is the database itself, and then we will discuss also the database management system, DBMS, and then later on we will discuss the database data model. So previously how they've been developed, and then what the current development of database data model, and then on the step or the life cycle of creating a database, and then GIS Database Application before we move to the development in database, before we can conclude it. So as an introduction, so before that, some question to ponder. What are database, and then what is different between database and database management system, DBMS. So we have two terms over here, database and also DBMS, database management system. What is this? And then why are database is important in GIS, and then what type of database are used in GIS, and then what is data model, and so on. And then how does the relational database model work, and then how do you set up a relational database, how are database linked with GIS, and then before we can ask about what are the important consideration for GIS database. So this is question to ponder throughout this chapter 4, database attribute management. Okay, so we have data from various sources, from GPS, from field survey, from remote sensing, from UAV, from LiDAR, and so on, from other agency give it to you, or we buy data from different agency. So they have different type of technique. So this is technique how we're going to merge it, and then we can show all the data in the same view. So this data is very large, how to store it inside the database. So this is some introduction. Okay, so the method of data management, to store data, to edit data, to do some analysis on the data, is using a database. So database in GIS currently being used by large agency in utilities, for example, in government, and so on. So database has been integrated in GIS from the automated mapping. It means that online mapping and so on, automatically we map the data to the decision making. Right. So in GIS, as we know, we already discussed a little bit on this. We have two types of data: the spatial data and the attribute data. So spatial data will tell us where the things are, okay, where the object is, the location of it, the point, the line, and polygon. Okay, and then the attribute, we have the attribute data, means that what is that location is all about, what this point is all about, what is the line, and is it a road, is it a river, or utilities, or pipeline, and so on. So they will tell us, the attribute data will tell us about this, all other what the thing is all about. So to manage this both data, we need a database. So this is the example of database in GIS, or not database, is how the data, two type of data being integrated. So we have the location of the data, and then we have the table that will have the attribute of that particular object. For example, we have a school, so they have the name of the school, we have how many people, how many teacher, how many students, how many administrator, okay, how large is the school area, and so on. So this is the attribute about that location or about that school. Okay, So this table can be using database management system. Also, they can integrate or link or have some relationship between one table to another table. So the importance of database. So database, we have maybe 2 type or 3 type of data. So they will have some connection between this data. So the same data used by different user means that all this data can be used by staff. All data by a person can be used also as a student. So student can be divided into 2. For example, undergrad and postgrad. On these 2 type of student, maybe is a local student, Malaysian or international student. Okay, so all this different type of data can be used by the same person or the same administrator. So this is the important of database, means that we have several type of data, and then this data can be integrated into database, and then they can show the location of that area with different type of agency, from different type of agency. For example, we have some lot. So this lot is the tax is managed by agency A, and then the land use being managed by agency B. So means that the same data is managed by 2 different agency, but we can connect between these 2 agency, the information from these 2 agency using database. Okay, so database is a collection of related data. So means that we have as I said previously, we have the same data, and then from different agencies. So we can create some database. We can create database about that particular location. And then data can be shared by different selected user. So we can also divide it or can categorize the user into several category: simple user, public user, administrator, data editor, database administrator, and so on. So we can categorize using database. So, and also data can have security, means that the public user cannot access the data from the local user or the administrator. Administrator can show all the data and can view all the data and searching all the data. And then certain person can also can only view some data and can edit only some data. For example, we have bendahari. Bendahari is the person in charge on the financial. So we have financial in UTM. So that particular person or that particular department can only change or edit data about financial. They cannot change our data about the courses, about the faculty, and so on. So the person in the postgraduate office can only change or view data about the postgraduate student. So they cannot change the undergraduate student. So they have more secure database data level. And then data was easy to access. You can access data from various places in the world. So for currently, for example, this e-learning in UTM. Okay, this is a database about. They have some database about the subject, about all the material, the tests and quizzes, and so on. So they can store inside one e-learning, and then they can access throughout the world. Okay. So database management system. So database is how to manage all these tables. So database management system is a software application, computer program to access and manage the database. The database is how to manage the table. So database management system is how the system can manage the database. This is some definition on DBMS and database. So inside database we have the entity or some diagram. Some person you call it a class. We have the attribute, and then we also have the relationship or association. Okay, so before that, before we move on, we discuss a little bit on the data model. So data model, we have 2 types in database. So the first one is the record based, the second one is the object based. So the record based is the previous development of data model in database, and object based is the current development or the latest development of data model in database. So in record based, they have several kind of record based data model: hierarchy, network, and relationship. So after that, this one is developed in early 50 until 90s. So the object base has been started his development from late 1990s until now. So currently they have object oriented data model. So previously they had hierarchy, network and relationship data model, and then they swap into the object based data model, starting with entity relationship and then semantic, and lastly is the object oriented. So this is the difference between two type of diagram in database design. So the left one is the entity relationship diagram, ERD, and then the right side is the class diagram. The class diagram lah. Okay, class diagram has been developed in late 1990s until now. So it's under UML. Okay, so we have here in ERD they call it entity. In class diagram they call it class or classifier. Then they also have attribute. The same name used by class diagram. The attribute, this is the attribute, this is the attribute, this is the attribute. So this is the attribute for ERD, this is the attribute for class diagram. And then over here they have diamond shape over here. This is a relationship between entity and entity. So in class diagram they only have a straight line or several type of line. They call it association. So means they associate how they associate between one class with other class. So in ERD is a relationship between one entity to other entity. So relational database model. So currently GIS software using relational data model. So they also using OO, currently developed using OO in ArcGIS. So shapefile is based on relational database model. Okay, so this database will, or this table will allow queries between relation or table inside the database. So one table can only store one entity. So this is example. So this is one entity, means that is one table. They have 3 column. So this is table about student. They also have 3 column or 3 attribute. So means that one table can only store one entity. So this is some terminology in database. So the whole table they call it relation. Okay, and this is the column they call it attribute, and then the row they call it tuple. Okay, so this is the relation. So the number of tuple, number of row, they call it cardinality. The number of column they call it degree. So almost each of the table or each of the relation, each of the entity will have a primary key or the unique key, unique column that will tell about this particular row. So this primary key B005 is unique for this row only. Okay, this is primary key. So this table, the primary key is branch number. The primary key is staff number, and then the foreign key to link between this table with branch table is we call it foreign key. So over here on the bottom we have the formal term in attribute. In database they call it relation, tuple and attribute. So relation in other term they call it table, and other term they call it file. So tuple also known as row and also known as record. So attribute also known as column and also known as field. So this is either attribute, they call it attribute, or column or field. So this one is row or tuple or record. Okay, and the whole thing is a relation or table or file. So this is some terminology in database. So this is some relational database model. So we have example this hotel. So database will allow the queries on the hotel, what the ID, what the name of that hotel, where the address, what the number of room they have, and then is it the standard or not standard. So the queries will based on the selection, projection. So selection based on column, cell projection, selection based on row, projection based on column, and other. They can join selection, means that they can ask question from table question from branch table and also staff table. Then they will have some one information listed down. So the query is based on standard query language or SQL. SQL, they call it SQL. So SQL is a simplification of mathematical equation. So to create database, so they need to have entity and relationship, or they have class or classifier and association. So they need to have some DDLC or Database Development LifeCycle. So this is 6 steps in database development or database storage lifecycle. DDLC, the first one is database preliminary study, and then second one is database design, the third one is implementation and installation, the fourth one is testing and assessment, the fifth one is the operation, and last one is management and maintenance. So this is the detail what step is, what happening in each step. In database preliminary study, they define what the problem is, what the requirement of the agency, and so on. And then they define what the objective of the database being developed for what. Okay, is it for financial or for project management and so on. And then they define the scope and boundaries, what this all about, what is should be included, what should not be included or should be excluded. And then the database design, they do the resource requirement analysis, okay, and also they design the conceptual design, and they select the software, or design the logical and also physical in database design. And then implementation, they install the database, develop database, and insert all the data related. And then they test the data, is it okay or not, the application can be run or not. Then they fine tune maybe some adjustment over here, and then they can access the data. Access the database means that is it can be run, is it good or not for this certain user. Then they operate. And lastly is management and maintenance. They run the application, do some improvement, and do some monitor and maintenance. So this is example of GIS Database Application. So GIS Database have several type of user. The first one is single user, means that they only have one desktop database. One database is developed inside one maybe computer only. And then they have multi-user, means that they have one computer store the database, and then but can be accessed by different laptop or computer or gadget. Okay, and then they have local user distributed database, means that they have store data in different computer and distributed information. Okay, lastly is the public user, means the cloud, for example the cloud database or storage. So for example it's our Gmail database, so data about us is being stored a little bit by Google. So some issue with the database, but some of the issue has been resolved by the current database developer. The complexity, if you don't know how to develop database, it will be complex. Okay, but if you know already how to design database, it will be quite easy. And then the cost of database is quite high. Okay, and then if the database is not developed efficiently, it will be inefficient. Means that if you're not based on the user requirement, you not do the first analysis, the user requirement analysis, then it will not be efficient, and maybe they will not use your database. And then the format, the format of database, is it hard to change between database? So currently it's not an issue anymore. Maybe some of it still have some issue because some restriction from the previous from certain software to other software. And then this database need to have a backup. So anything happen, they need to have some backup. Okay. Okay. So some development in database also. So currently in GIS they're using object oriented, not irrational anymore. For example in GIS, the current one, we have file geodatabase and also personal geodatabase. So this is based on object oriented. It's not based on object. It's not based on the relational anymore, but on the object. So this is some description on the encapsulation, inheritance, and polymorphism. So this is example of database entity. So they inherit this one information from other entity. For example, accommodation, and the information about accommodation is for example, the location, one inside the accommodation, and then they divide it into two type of accommodation: tourist and residential, and other type of division: pension, hotel, apartment, flats, and houses. Okay, so as a conclusion, this chapter discuss a little bit what is the attribute data management. Okay, we have the spatial data and attribute data, and then the importance of database. We also discuss a little bit on the difference between database and database management system. We also discuss a life cycle in developing a GIS, and then some issue in database and the current development of database in object oriented. I think that's all for this discussion, chapter 4, attribute data management. So hopefully you understand. Thank you very much. Assalamualaikum and see you again.